All right, ladies, this is going to be your classwork, and what you don't get done today needs to be finished for Tuesday's class and submitted to Moodle. But this is what you're going to be working on, and you're going to be calculating your carbon footprint. So you're going to be looking at fossil fuels, the amount of fossil fuels that are used in Louisiana. So I'm going to scroll down a little bit and get some background information at the top. But you're going to be looking especially at Louisiana, and here's a graph that shows you just how much fossil fuels, energy consumption, that Louisiana used in 2015. And you're going to have lots of questions to answer. Now, part 3 is where the really important information is. Because you're going to write and balance an equation for LPG, which stands for liquefied petroleum gas. Notice that you are given the formula for this LPG right there. And you're also given an amount. Now notice it's in kilograms. Don't forget to convert that into grams. And you're going to go ahead and do that 2 more times, where you're going to write and balance an equation for natural gas. Once again, it tells you that natural gas is methane, gives you once again an amount of methane. Once again, in kilograms. Don't forget to convert it to grams. And last but not least, you're going to do the same thing for gasoline. And once again, the formula for gasoline is given to you right there. And you're going to write and balance an equation for gasoline. Now, the gasoline part, that's the part that's going to become very personalized to you and where you live and how much driving you do. So you're going to go ahead and Google some information about how far you live from school, the route that you take. Maybe you take a different route. So make sure that you're Googling the actual route that you take to school. Don't forget to multiply it by 2 so you can figure out what your mileage is. Then you're also going to look at if we're in school for 180 days. Of course, this year's a little different. But if this was a regular school year, you would be in school for 180 days. And so make sure that you can then multiply your to and from school distance times that 180. Now, also, you're going to look at if you have a job, driving to that job. Or maybe you have a practice that you go to for dance, gymnastics, cheer, whatever it may be, track, swim. Whatever it is, and you drive, or even if you just ride in a car to and from practice. Once again, Google that distance. Don't forget to multiply it by 2 and how many days a week you do that. And that's going to give you your total miles that you drive or ride in a car every year. Now, once you get past that part, now you're going to start doing lots of dimensional analysis using those numbers that you just calculated for your mileage. Now, if you know the mileage, gas mileage that your car gets, go ahead and use it. If you don't, go ahead and use this average gas mileage right there. It's 21.6 miles per gallon. Okay? So you're going to use that to calculate how many gallons of gas you based on your yearly mileage. So you're going to use dimensional analysis. What is dimensional analysis? It is just like stoichiometry, where you're going to use railroad tracks. You're going to look at your units, and you're going to make sure that the units at the top left can cancel out with the units at the bottom right. So if, let's say, I drive 550 miles a year, okay, I'm going to put that up in that top left. And then I'm going to go ahead and use my 21.6. So I want to put 21.6 miles. And then 1 gallon here. Then I'm going to do my calculation. Now, don't forget, everybody is going to have a different number here because everybody lives someplace different. Everybody has different jobs, different practices. So everybody's going to have a different number right there. But this is what dimensional analysis looks like. It's train tracks. It's making sure that units cancel out and what you're left with at that top right is what you're supposed to be finding, what your problem is asking for, okay? And you're going to keep doing this dimensional analysis work. So from here, you solve for your gallons. Then from here, you're going to take that number of gallons and that was in part F. So number of gallons in part F. And once again, you're going to here's your next conversion factor. So realize all dimensional analysis is really doing is allowing you to convert to different units. So once again, we see 1 gallon and we have 3.785 liters. And punch and crunch. Then you're going to do the density of gasoline. So if you solve for your liters here in part G, you're going to use that number to solve for the kilograms of gasoline used per year. Don't forget the equation for density is density equals mass over volume. And you are going to manipulate this equation so that you're solving for mass. Now remember, your mass is going to be in kilograms. So that information, that all that solving that you did for the gasoline part will be used right here to do stoichiometry. Okay, now the stoichiometry problems for LPG and natural gas, that is going to come from part 3 way up at the top. So if you keep scrolling, let's see, natural gas, look, there's your number right there for the stoichiometry part. Once again, there's your number right there for the LPG. But notice, ladies, these are in kilograms. So you need to convert your answer for the gasoline, the given information for the LPG and the natural gas. All three need to be converted into grams. Once you have that done, you are going to be doing calculations where, for like in this first part, you're going to be going from grams of LPG to grams of CO2. Don't forget to use your balanced reaction so that you have the proper numbers in your mole ratios. You're going to write your answer here. And then you're going to do another dimensional analysis where you're going to convert your grams into pounds using the conversion factor that you see up at the top. So you're going to do all of those and finding out how many pounds of CO2 is made in Louisiana. And of course, this is for 2015 for LPG and natural gas. And then your own personal gasoline use is going to go into this third box where you're going to do the stoichiometry here. And then you're going to add up all these pounds so you can see the total pounds of CO2. Once you've done that, and you probably are going to get a pretty large numbers. My girls who have done this in the last 2 years have gotten some really large numbers. Like they were very surprised at how big their numbers were. So don't freak out if you get a big number. Then you need to go ahead and do this analysis. And it's just kind of a reflection of your numbers as compared to what's used in the US and the average for the world. And then this needs to be submitted to Moodle by 8:30 on Tuesday, March 31st. If you have any questions, don't be afraid to either Skype me or email me.